Okay, this is overview of the Spark basic filtering operations. The dataset used is Yellow Taxi dataset. These are the types found in this dataset, fields and their types, and these are various files which encompass almost 5 years. And let's start. Okay, filter records where trip distance is greater than 5. This is done in multiple ways. Via column, via expression, via filter, via where, or and via straight SQL. Each time the result is printed and is the same. Here I decided to test which way is actually faster or optimum, and this is generated benchmark function which has start time, end time, and it executes some custom function, in our case lambda, and makes count, which means that it forces execution and then prints the average time. The whole test is done in 4 runs, and these are various lambdas which are passed over here as a function. So basically, what we see here is being executed here. This is a string title, and this is actual implementation of the expression. So two filters, two wheres, and straight SQL. Actually, on the first run, we might believe that filtering via column might be faster. It's a bit faster on the first run. But this, the next run shows it is not. And then again, here it's almost the same. Here it's again faster. So there is no basically difference which way you run. The result is the same in terms of performance. So all 5 methods of filtering, filter call, where call, filter expression, where expression, and SQL operate at almost the same speed. Okay, filter column equals 1, passenger car count is 1. Okay, this is between. Between can be done this way, and here we check it. So uh, so I checked if the ends are included for between operation, where column is 10 and where column is 20, so both ends are included. So see, here we have various numbers. Here we have 10, here we have 20, so ends are included for between statement. Okay, filter airport fee greater than 0. Uh, Next is checking for is null. So we got airport fee null. Okay, payment type 1 done by column. Okay, double filter tolls amount greater than 0, trip distance greater than 0. Pay attention, the sub expressions should be put in parentheses, and this is end. So we have toll amount greater than 0, trip distance greater than 10. The condition is satisfied. So filtering by string flag, checking against a certain value. So story and forward flag, yes. Okay. Now getting date formatted to a certain pattern and then checking it. uh, the thing. So it's basically pickup type. So all pickup times come under this specific date. Okay, the same task done when you cast to date. So this was done by date format. This is done by cast. The result is the same. This is another way of doing it function to date. Again, the result is the same. Basically, this is what we're interested in. Okay, expression date equals, so we have double quotes and single quotes. Again, the result is as expected. Okay, uh, date time column is given substring, is also providing the results. These are 10 symbols of the date. Next, okay, next is comparing, straight comparing is again, the result is the same. And finally, this is SQL expression to date because certain value, the result is the same. And here, another SQL expression using cast. Again, the result is the same. Okay, this is attempt to add date time column based on expression to date. Okay, we have a list. Now this is benchmarking. I decided to benchmark which way of filtering date is actually the best. And here the results are different. So date format is pretty slow in all cases. In all three cases, date format is slow. Substring even slower. And the rest of the methods actually doing fine. Fine. So cast. Okay. So which methods are actually good? So cast after column is a fast method. Today around column. To compare expressions are good. This is bad. And cast inside SQL expression is also fast. So these two, substring and date format, are slow. So don't filter by date format or by substring. Okay, either condition is true, not sure if this case shows, but it's true. So passenger car count is greater than 0. Second is doesn't matter. Okay, even more expressions, double filters. This can be done via expression, or this can be done via two columns expressions. Both results are the same. So trip distance is above 8 and total amount is above 40. Also, you can use filter and way and vice versa. Okay, next. Okay, again, two comparisons by expression. The condition is or, so it's met. Okay, payment time 1 and tip amount above 5. Okay, we got it. Airport fee 0, toll amount 0. Okay. Passenger count greater than 2 and trip distance between 2 and 10. So we can do it by expression using between, or we can do it via columns. This is greater than equal to. This is between 2 and 10. And as you can see, I put them in the parentheses. Maybe this is not required in the second case, but it It is certainly required here. Okay, two fields compared, 0 or 2. Okay, the expression is actually or. Okay, next thing, um, fay amount and tip amount. Okay, satisfied. Okay, three expressions: passenger count, one of passenger count, two, and fay amount above 15. So this is the result. No samples of two. Okay, okay. Next, here is extraction of months using date format, but this is not the fastest way. I believe using the function month is better. And airport fee is greater than zero. Again, additional parentheses. Airport fee and month in pickup time is 1. Next. Okay, trip distance greater than 12, total amount greater than 60, and tip amount greater than 3. Okay, condition is met. This here is the second met. Total amount greater than 60, but not trip amount greater than 12. And here is tip amount greater than 3. Okay, these were simple conditions of Spark demonstrated on Yellow Taxi New York dataset.